This video is hypothesis testing with 2 samples part 2, and we're picking up with example 3. Post-surgical treatment. A new post-surgical treatment was compared with a standard treatment. 7 subjects received the new treatment while 7 others, the controls, received the standard treatment. The recovery times in days are given below. So here are the recovery days for the treatment group, and here's the recovery times for the control group. So can you conclude that the mean recovery time for those receiving the new treatment is less than the mean for those receiving the standard treatment? So let's figure out what is the claim. So they want to know if we can conclude that the mean recovery time for those receiving the new treatment is less than the mean of those receiving the standard treatment. So that would be our claim. So I'm going to write the null and the alternate statement up here because there's not a whole lot of room on this page. So the mean of the treatment group is equal to the mean of the control group. That would be our null. Our alternate statement usually goes along with the claim. They're claiming that the new treatment times would be less than the mean of those receiving the standard treatment. So the mean of the new treatment times is less than the mean of the standard treatment or the control group. Okay, so I'm going to do a 2 sample t-test because I'm testing two populations and their means. I've taken 2 samples, or they've taken 2 samples. Now the samples are given as raw data, so L1 and L2 will be right there. Okay, so where it says list 1, we're going to put L1. Where it says list 2, we're going to put L2. Where it says frequency 1 and frequency 2, we're going to leave 1, and then we're going to choose that the mean is less than mu2. I'm going to pull up the calculator, and I'm going to move it over here, and I'm going to go to L1, stat, enter, and clear out the list that I put in for, I believe that was from example 2. I'm going to put in the data for example 3. So in L1, I'm going to put in 12, 13, 15, 19, 20, 21, and 24. 12, 13, 15, 19, 20, 21, 24. So always double check. 18, 23, 24, 30, 32, 35, and 39. So 39, 35, 32, 30, 24, 23, 18. Okay, I've got the data in, so now I'm going to quickly run the test. Stat, tests, choose 4. Make sure you choose data. List 1 should say L1, list 2 should say L2. Frequency 1 and frequency 2 should be 1. My alternate statement should be less than, so choose less than. Make sure you hit enter for less than. Pooled should say no, and calculate. P-value is 0.0036. 0.0036. So our p-value, 0.0036, is less than our significance level of 0.05, so we are going to reject the null. And if we reject the null, that means there's enough evidence to support the claim. So can you conclude that the mean recovery time for those receiving the new treatment is less than the mean for those receiving the standard treatment? Yes. We can conclude the mean recovery time for those receiving new treatment is less than that of standard treatment. Alright, so example 4, King Tut's curse. King Tut was an ancient Egyptian ruler whose tomb was discovered and opened in 1923. Legend has it that the archaeologists who opened the tomb were subject to a mummy's curse, which would shorten their lifespans. A team of scientists conducted an investigation of the mummy's curse. They reported that the 25 people exposed to the curse had a mean lifespan of 70 years with a standard deviation of 12.4 years, while a sample of 11 Westerners in Egypt at the time who were not exposed to the curse had a mean lifespan of 75 years with a standard deviation of 13.6 years. Assume that the populations are approximately normal. Can you conclude that the mean lifespan of those exposed to the mummy's curse is less than the mean of those not exposed? Use the significance level equal to 0.05. Alright, so I'm going to let you pause the video here and try to do this whole thing by yourself, and when you come back, I will have the answer. Okay, so for this one, for the null, we had the mean of those exposed is equal to the mean of those not exposed, and we're trying to conclude, because this was the sentence up here, the claim rather, can you conclude that the mean lifespan of those exposed to the mummy's curse is less than the mean of those not exposed? Use a 0.05 significance level, so I made the alternate statement, the mean of those exposed is less than the mean lifespan of those not exposed. So I chose a 2-sample t-test, and I chose statistics because they gave us the stats for the samples. The sample mean of those exposed was 70. The standard deviation was 12.4, and the number was 25. The mean of those not exposed was 75 with a standard deviation of 13.6, and the number in that sample was 11. So we ran the test as a less than, because that's what it was asking up here, less. And the p-value that I got was 0.1554, which is greater than the significance level of 0.05, which means that we fail to reject the null. And if we fail to reject the null, there's not enough evidence to support the claim. So no, we cannot conclude that the mean lifespan of those exposed to the mummy's curse is less than the mean of those not exposed. Okay, so now we've done the 2-sample t-test. Now let's talk about the 2-prop z-test. Now, just a reminder, you're not going to have numbers in the null or the alternate statement. It's just going to be P1 and P2. So you'd write the null P1 is equal to P2, and the alternate would either be P1 is less than P2, P1 is greater than P2, P1 is not equal to P2. So let's look at example 1. The National Health and Nutrition Examination Survey, NHANES, weighed a sample of 546 boys aged 6 to 11 and found that 87 of them were overweight. They weighed a sample of 508 girls aged 6 to 11 and found 74 of them were overweight. Can you conclude that the proportion of boys who are overweight differs from the proportion of girls who are overweight? So here's our claim. We want to know if the proportion of boys who are overweight is different than the proportion of girls who are overweight. So for my null, proportion of boys is equal to proportion of girls. So we're saying that there's no difference. And for our alternate statement, proportion of boys is differs, so not equal to proportion of girls. Now we're going to do, because we're talking about proportions, we're going to do a 2-prop z-test. It's going to ask us for x1 and n1 and x2 and n2, and it's going to ask us for our symbol. Alright, so let's go through the list. The x1 would be boys. So the number of boys who were overweight is 87 out of a total of 546. The number of girls who were overweight is 74 out of a total of 508. And we're trying to show that it differs, so that it's not equal to. Alright, so let's pull up the calculator. So we're going to go to Stat, Tests. We're choosing 6, 2-prop z-test. Oops, I did that wrong. Let me do that again. 6. X bar, not X bar, X1 is 87. 546 is the total. X2 is 74. 508 is the total. We're choosing not equal to. And we go to calculate. It looks like our p-value is 0.5376. 0.5376. So p-value is 0.5376, which is definitely greater than any significance level. So let me look through this again because I don't see a significance level. So if there's no significance level, compare it to 0.05. So comparing it to 0.05, we see that it's greater than, so we're going to fail to reject the null. So we cannot conclude the proportion of boys who are overweight differs from the proportion of girls who are overweight. Example 2, pollution and altitude. In a random sample of 340 cars driven at low altitudes, 46 of them exceeded a standard of 10 grams of particulate pollution per gallon of fuel consumed. In an independent random sample of 85 cars at high altitudes, 21 of them exceeded the standard. Can you conclude that the proportion of high altitude vehicles exceeding the standard is greater than the proportion of low altitude vehicles exceeding the standard? Use 0.01 level of significance. So why don't you pause the video and try this one. Pay attention to how they worded this. The proportion of high altitude is greater than the proportion of low altitude, yet they give you the low altitude first, so you might want to flip-flop your x1 and your x2. Okay, so we ran a 2-prop z-test. Our null was p. The proportion of high altitude is equal to the proportion of low altitude, and the alternate is the proportion of high altitude is greater than the proportion of low altitude. I made sure that my x1 and my n1 were the high altitude, so the 21 and the 85, and the low altitude was the 46 and the 340. And I flip-flopped that because of the way they put the order of the claim, because they claim the high altitude is greater than, and I wanted to put greater than the low altitude, so I wanted to make sure that that was correct in the calculator. My p-value was 0.0057, which is less than 0.01, so we reject the null, and we can conclude that the proportion of high altitude vehicles exceeding the standard is greater than that of low altitude vehicles, because we had enough evidence to support the claim. Last one. Example 3, preventing heart attacks. Medical researchers performed a comparison of 2 drugs. I'm not even going to try to pronounce that, or the other one. We'll say the C drug and the T drug, which are designed to reduce the risk of heart attack or stroke in coronary patients. A total of 6,676 patients were given the C drug, and 6,732 were given the T drug. Of the C drug patients, 668 suffered a heart attack or stroke within 1 year. And of the T drug patients, 569 suffered a heart attack or stroke. Can you conclude that the proportion of patients suffering a heart attack or stroke is less for the T drug? All right, I'm going to pause the video and let you try to work through this, and when you come back, I will have it worked. Okay, we ran a 2-prop z-test. We said our null was the proportion of the T drug is equal to the proportion of C drug. The alternate statement was the proportion of the T drug was less than the proportion of C. I made my H1 and N1 the T drug, and my H2 and N2 the C drug. I'm going to put that data in with a less than sign. I found a p-value to be 9.399e negative 4, which is 0.0009 when expanded to a regular number, which is less than 0.01, so we rejected the null. So that means there is not enough evidence. I'm sorry, that means I wrote that wrong. Oops. That means that there is enough evidence because we rejected the null. There is enough evidence to conclude that the proportion of patients suffering a heart attack or stroke is less for, I'm not even going to try to butcher that, I'm just going to say the T drug. Okay, So that's all for this section. Let me know if you have questions.